So, when we talk about naturally occurring soils, and there have been lot of questions regarding this, these are basically from disintegration of rocks, which we discussed some time back. There are three types of rocks you must have studied. Very good. Sedimentary, then why I have written like this? Metamorphosed or metamorphic? So, this is basically rock cycle, is it not? So, sedimentary to metamorphosed or metamorphic, and further action of pressure and temperature and all the agencies which we have discussed, the carriers. Mostly this is P and T, pressure and temperature condition. So, sedimentary is the one which is, remember Himalayas, there is a lot of weathering process going on, big boulders getting formed, they keep on hitting each other, they get fragmented because of the flow of water. Each fraction further keeps on becoming smaller and smaller by the time it comes to the Gangetic plain. And then something happens from Gangetic plain up to the Calcutta, Hooghly, all these areas. What happens? Even the small particles become much more finer, alright. So, conversion from very big size to medium size to the finest size, and this is a journey which the material is following. In geological terms, time scales. So, sedimentary is something, please understand this concept carefully, this is going to be useful forever. You have seen deltas, alluviums, fan formation. Sundarban is a beautiful example of the delta which has got created, at the junction of Bay of Bengal and Hooghly river. So, what has happened? Suppose if you do the mechanics of this problem. So, the river is bringing sediments. What are these sediments? These sediments are the disintegrated form of the rocks which are coming all the way from Himalayas, mountains, clear? And they have been travelling so long in terms of time, in terms of distance, and they got fragmented, they got super fine. Weathering process, somebody was asking what is weathering. So, these rivers have lot of suspended loads, we call them as sediments. Alright. Mostly this is fresh water. Try to capture the attributes. So, for an engineer the attributes are very important. So, the keywords which I use, what did I do? I said river, and then I said suspended load, from where suspended load is coming, from all that weathering process, agreed. And then suddenly I brought in the concept of fresh water. What fresh water has to do with in this context? Density of the fluid, clear? So, the fresh water, let us say, because I am sure all of you know that from the stretch of the Himalayas up to the certain portion where the Ganga comes, water can be just drunk without filtering it, and then the human activities start and the water becomes polluted, clear? But then there was a time when people used to drink it up to Varanasi or Allahabad or Gaya and Prayag and what not, clear? So, this is the fresh water, density is going to be less, and this suddenly comes and meets the Bay of Bengal. I am sure many of you would be taking it up as a research project in your career in whatever form, I do not know. So, it is very deceptive. You right now you think I will never do this, ultimately you end up doing this. Even if you become a CEO of a company, you will realize that most of the development is going on now in these areas in the country. Clear? Most of the companies are establishing themselves over here. Now, what I am going to tell you is, this is typical sea water. What is the emphasis? Why I am saying this sea water? Salt is fine, density, correct? Density contrast. So, if this was rho 1, this has become rho 2, where rho 2 is greater than rho 1, clear? What is going to happen? A lighter fluid entering into a denser phase. What is going to happen? Sorry? Say it loudly. No. Yes. Someone else? What are the attributes of the system? This system is fresh water having lot of suspended loads. Imagine you must have, all of you must have realized the turbulence in the aircraft when you travel. Why do you face turbulence? Jittery it becomes. Why? So, you are going from a lighter phase of the air into a denser phase, clear, particularly when you land, then most of the problems come. And when you take off, imagine, close your eyes, what you are doing? You are going or you are moving into a denser liquid and again coming out into the lighter liquid. Is this correct? So, the same thing is happening over here. The rivers carrying suspended load and these suspended sediments are entering into a denser phase. What is going to happen? Velocity reduction, number 1. The moment velocity reduction occurs, all these sediments will have a tendency to settle, correct? Sedimentation process. Is this part clear? The rocks which are formed because of the sedimentation process. Now, what are the major players in the formation of the sedimentary rocks? Simple process like this, loads of sediments which are present in the fresh water, they are entering into a system which is denser. Sediments have a tendency to settle down. Now, look at the micro mechanism, what is going to happen. So, if this is the river bed or ocean bed or whatever it is, I will say water body bed. So, this is the bed of the water body, clear? And imagine this is the fresh water. Normally water we depict like, you make a triangle and draw something like this. This becomes a water level, clear? Connotation is like this. For soils we show a horizontal line and this is the ground level. Is this okay? So, all these sediments, mostly coarse grained materials, they keep on settling. Initial process. Next load of sediment comes, it gets deposited like this. The whole process is happening under gravity, clear? Nothing else. In the process, somebody was asking about bacterial action. Might be a situation where the bacteria starts secreting something and they all become a cohesed material. Cohesed means cohesion. Individual grain is now getting glued because of either microbial activity or it could be because of physical activity also. Suppose if I take two particles, take two balls and press them hard, cold welding, what happens? There is a contact which you have created, very high pressure, clear, and low temperatures, alright. Otherwise everything is going on with self weight. Later on I will use this concept to define the state of the material in engineering aspects, that how you are going to make buildings on these type of formations, clear. Now, this system gets metamorphosed because of several things. pressure, temperature conditions, chemical conditions, temperature, fire, whatever, becomes metamorphic. Under extreme temperatures and pressure, this becomes igneous, it becomes magma, it becomes highly uniform system. So, these are the igneous rocks. I hope you are aware of some of the examples. You can write what are the examples of sedimentary rocks? Sandstones, clay stones, limestones, mudstones, shale, conglomerate. Fine. I will repeat: sandstone, limestone, mudstone, shale, and conglomerate. Should I write or is okay? It's okay. What are the examples of metamorphic system? Yeah, so we were talking about this metamorphosed or metamorphic rocks. So, when the temperatures are very high, the type of rocks which you are going to get formed is marble and quartzite, and when pressures are very high, what will happen? Then you have slate and schist. Slate, see, if pressures are very high, I write normally like this: if pressures are very high, then you have marble and quartzite. And when temperatures are very high, what is going to happen? Shale and schist. And I think sedimentary rocks, I have given several examples, all sorts of limestone, sandstone, clay stone, they form this category. Igneous rock, under acute pressure and temperature conditions. Any examples of igneous rocks? Basalt, granite, alright, they form the category of igneous rocks. Now, soil could be formed because of the processes which we have already discussed out of any of the three. So, A, let us use S, M, I. So, you have a triangle, sedimentary to metamorphic to igneous, and further disintegration of igneous might get resulted into the sedimentary also, clear, and at any stage of this you might find soil getting generated. Only thing is that this is the functions of pressure and temperature, the conditions. Is this okay? Now, what this has to do with the definition of the soils? You remember we were talking about the attributes, profession, then we were talking about uses, then we were talking about what is the origin, and now we have to talk about the transporting agencies. Is this fine? One question which comes automatically is, what is the difference between rocks and soils? Any idea? Again, this has to be profession dependent. Again, it has to be process dependent. By thumb rule, if I need to cut anything or if I need to blast anything, you were talking about reclamation. Is this correct? Okay. So, if I have to cut something or if I have to blast something, that means a hard system. Normally rocks are cut and blasted. There are different type of cutters. Right now metro work is going on in the entire Bombay city. You can go and visit what is happening there, how they are cutting the entire rock mass. What are the tools which they use to cut the, we call them as tunnel boring machines, TBMs. There are very good videos which are available on the websites, YouTube and all. You should be, you can watch them. I won't advise you to go inside, because sometimes back when I took some of the students there, one of them fainted at 80-meter depth. Most of you are not physically very fit, is it not? There is a phobia, there is a blood pressure, and there are a lot of other diseases which you guys have, and under these sub environmental conditions, mostly people get panicked. So it's not a very advisable thing to carry everybody there and ultimately inviting a lot of problems for yourself. It requires a lot of mental strength, I would say. I have some videos which I can show you privately of the tunnels which are being done in Bombay city. Anyway, so coming back to the point, rocks are the ones which need blasting and cutting. Normally soils are not of that type, they are mostly excavated. Okay. So this is one of the difference as far as a very layman's language is concerned, that rocks need cutting and blasting, soils normally do not. But it may so happen that soils also might require some cutting, by the way, but definitely not the blasting operations. You must have studied the Mohs scale of the hardness of these materials and so on. I can say that these are the parent material, these are the offsprings, and hence the matrix. You understand the matrix? Matrix means texture. Texture is okay. I mean, this texture is very fine as compared to the one which you are wearing. So the physical appearance, all right. So the texture is different. Rocks are mostly, I can't use the word very smooth, because sedimentary rocks are not going to be smooth, clear. So they are basically made up of stiff matrix, okay, as compared to the soils, all right. This is another way of defining or maybe differentiating, but it so happens that the mineralogy is going to be same. Why? That is DNA. The linkage is going to be between the parents and the kids, genetics, clear. So the mineralogy of this system is going to be same as the mineralogy of this system. But somebody was asking here about that the mineralogy may also get altered. I don't remember, but somebody had hinted on this, So it may so happen that chances are that whatever minerals are present in this form, in a very intact form, dense form, clear, would be present over here with or without abnormalities, agreed, but not in that much dense matrix. Is this okay? Now this is what you are asking is a research idea. So I remember long back when India was initiating this Mars mission, ISRO had sent some samples of the Martian soils to my laboratory. I was a part of that mission. We were testing those samples, all right. So I was trying to understand myself that what would be the relationship between the two. You got it? That is what NASA does. They will take out the samples of the rocks and they will send some rock rovers, land rovers, and what do? They will detect by using some X-ray or some non-destructive way to find out the mineralogy, clear, and that mineralogy, if I can relate to this, my job is done. I have created a linkage between the two. Carbon dating is one of the ways to find out whether the origin of these type of soils is what. You got the answer to your question? Read more and more about this. It's a very interesting topic of research, and many people are working in these areas, particularly the guys who are into offshore engineering, those who are into hydrates, is it not, the origin of soils in which the hydrocarbons are present, or a particular type of mineral which you are looking for. So, as I said, you have to take care of this and your intentions. Put these two together to deal with the material. Got it? This becomes more of a intuitive task. Now, let us enter into the classification schemes of the soils. When we said types of rocks, alright, and I linked it with the naturally occurring soils, which is the origin. Let me talk about this is the classification scheme for the rock. Now, let us talk about the classification schemes which are used for soils. If you remember, in the beginning of the lecture I said creation is one thing, transporting agency is another thing which attributes a lot of knowledge into the system, and ultimate thing is how it gets deposited. You remember 3 stages: origin, transportation, and then deposition. And there I tried to give you some hints. Somebody goes outside, gets exposed to the environment, society more and more, as compared to the one who remains confined to one place, residual systems. Clear? We will talk about this now.
Yeah.
These are naturally occurring processes. You can contain, you can slow down, you can retard the process. That's an engineering, that's a technology. So, if you go to Middle East, if you get a chance to work over there, Middle East is famous for having big cavities in the formations, you know, subsurface strata which I was talking about. So, $1 million question there is, check it on net, why it is difficult to lay foundations in Middle East, most of the regions in Middle East. So, suppose if I lay a foundation over here, you never know there will be a big cavity over here. What is this cavity? Look at this, another example of you know, the chemical process. Okay, so see, coming back to your question and the one which you asked, these type of subsurfaces of the deposits are very notorious. Mostly they are limestone, alright, and they are sitting on in the coastal areas. Clear? What seawater has to do with this? Now, this seawater ingresses into the foundations or the strata, has a tendency to eat up the limestone and create cavities under a very specific condition of pressure and temperature and humidity. Now, this is what is known as lime dissolution. I was a consultant to Bandra Sea Link. I do not know whether you are aware or not. So, all the foundations have been designed and verified by me in 1998-99. A big problem was this: you might be laying a foundation over here and you never know there is a big cavity waiting for you. Hope you understand what is going to happen. Caving in. So, the moment traffic goes on the system, the entire pier of the bridge or the foundation might sink into the cavity. So, UAE, Sharjah, Middle East, Oman, all these places, the big problem is lime dissolution because of the seawater under very specific conditions of pressure, temperature, humidity, clear, and salinity, chemical process. And your question was, repeat your question now and link it with this.
My question was that whether the conversion of rock to soil is a desirable process.
So, here I have given you a phenomena where what has happened to the limestone? It has got dissoluted. Another extreme, clear? Now, whether it is, so the discussion was that nothing is in your control. You remember, this is what we were discussing. It's a natural phenomena. I can't stop it. There is no way I can put a containment like this. It can be done only on the blackboard. In real life, you cannot do it. Why? Water will come from down. Alright, is this okay? So, you can't control it, you have to live with it. Now, where is the engineering? Engineering is fully knowing the facts that this is going to happen. I should be having a strategy in my mind to counter it, so that if the entire system is going to sustain itself for 20 years, I will add another x years to this. That is my engineering and technology. You got this point? That is it. So, what technologies are doing? They are providing techniques like surgeons. What do? They do colon surgery. Clear? So, they will cut your intestine and they will connect it to the pipe. What I have done? This is the sea water. Have not I done the same thing? I have cut the access of the sea water from the structure by providing some bypass. Are you getting this point? No? We will discuss this in details. All right. Yes.
So another thing, can you tell something about what is happening in Run of Kutch? I mean, they also have the entire thing covered up with salt. So is there something like the soil is somehow changed in some way by the sea?
Rejuvenation of deserts. Read this topic. Write it down. Rejuvenation of desert areas. All right. And second is when you come down towards Bhavnagar and all these areas which are Run of Kutch type, what you are talking about, ingress of salt water into the soils. Clear? So, how would you stop this? How would you rejuvenate the entire land? Have you ever been to these areas? Why from all the way from eastern part of the country to the extreme west of the country?
I have recently been to Run of Kutch, and so
what did you saw there? What did you see there?
The festival. So means the Run festival which happens in the winters. So I had been there to visit it.
Government of India's atomic energy program depends largely on the bentonite which comes from that area. You know this, and I think I told you today about 1.5 hours back, if bentonite is not there, you can't run your atomic reactors. You understand? So, Run of Kutch is very famous for minerals, and nowadays you must have realized if you have gone towards the Pakistan border, Dakshineshwar temple is there.
No, I haven't been to there.
Google Pay, you can check. So, from there the border is hardly 35 kilometers. Now, this is the area where most of the mining activities are happening and most of the industries are being set up. So, I am consulting at 2 of the places there. Extra deep mines, somebody was talking about the mining in this sector, you know, somebody was talking about the mines. So, extra deep mines, when you do, what is going to happen? Salt water intrusion, salt water getting flooded into the pits and you do not know what to do, how to survive. It's corrosive water, clear? So, then you have to do something. Okay, so let us talk about the geological characterization of soils. Mainly this whole thing is including genetics into it. The heritage. You know, they have a family tree, family heritage, is it not? We call it as a genetics, genomics, whatever you may call it. So, most of the time geological classification is carrying a connotation of the geomorphological features of the soils. Geo is earth, clear? Geotechnical. Techniques which are going to be used to understand the materials which are lying inside the earth or on the earth, geotechnical, clear? And engineering with those materials. So, when we talk about this, the first thing which comes to the mind is these are 2 broad characteristics. The first one is transported, and I think you are all aware now what transported soils are, and the second one is the residual soils. transported soils after weathering is over, they get transported from one place to another place by a transporting agency, clear, and we discussed about 2-3 things. So, the transporting agencies, say it again, what are the transporting agencies you were talking about? Water, wind, not air, wind, there is a difference, use right language. Water, wind, gravity, sorry, human activities. Oh, very nice. The one which you have forgotten is ice, clear. There is another form of water, but ice is also a transporting agency. Why? Avalanche. How many of you have seen avalanche? Not only in Hindi movies and Hollywood, Bollywood movies, but in real life. How many of you have been to Manali, Rohtang and all these places? You must have seen avalanche, snow avalanche. What are the properties of snow avalanche? These are also geomaterials. Why? Anything which is resting on earth, even we are also geomaterials. Agreed? We come out of it, we live on it, we spend some time on it, and again we go back into it. Perfect example of geomaterials. And in the process, what not we do? All chaos we create. You agree? Is this fine? So, avalanche is also a sort of a geomaterial. Water vapors getting deposited in the form of the snow and settling down over the upper reaches of hillocks or hills, and under extreme low temperatures and high pressure, from where the pressure is coming. The first layer I was talking about, sedimentation process, that was a river induced. Now what happens? The first layer of snow comes, the second layer, third layer, and self weight compaction, consolidation, clear. We will discuss about this quite in details later on. And ultimately this whole thing becomes so hard. So the moment temperature changes, climatic conditions change, it breaks and it slides, it hits something, causes a disaster, alright. So transporting agencies are, as you are rightly saying, water, wind, ice, this could be any other human activity, gravity and so on, fine. Now like human beings, you know, we are in different continents, agreed. So why ice becomes a very important carrier or transporting agency? You go to another continent, Scandinavian countries, Norwegian countries, the countries where most of the time the entire thing remains snow bound. There is no free water on the surface, clear. So it is not possible that the rivers are going to carry anything from one place to another place, clear. So this is totally because of the ice effects the transportation could occur. There is another logic. Come as another, my suggestion would be, the soil mechanics which you are studying should not be confined to only Indian context. Ultimately what you want to become? You want to become an international guy. So geography should not bound you, you know, not geology, geography should not bind you. I have not talked about geography, I will talk about that also. Is this okay? Now if you look at the attributes of these materials which have been transported, attribute means, let us say, color and shape. How many have been to Gangetic plain, Brahmaputra river, or say Ganges or Yamuna and all those? So why I am asking like this? Transported soils, depending upon the transportation agencies, they will have peculiar attributes in terms of their shape, particles, texture, color. Why? So, if water is the carrier agency, what is going to happen? All these particles will be getting washed, I do not know for how many times in their entire life. So, what will happen? Shining particles, you know, and the more and more abrasion takes place because of the rolling effects. I hope you understand, rolling is taking place because they are coming from higher reaches. So, what is going to happen? The water acts as a abrasive, it gives the abrasive effect. So, the particles are going to be mostly perfect spherical in layman's language, not microscopically. Typical sands. Sands are one of the varieties of soils. Somebody who was sitting here said mud last time. Oh, yes. So, mud is a layman's language, clear. So, technically when we say soils, one of the variety of the soils would be sands, clear. Round particles, why? When they got broken because of the physical, chemical, biological weathering, they were all distorted. But look at this, the moment they started traveling from A to B, you remember, there were so many rollings which are occurring, water is washing them, ultimately what happens? They all become minimum surface area or maximum surface area. The sphere has a minimum surface area or maximum surface area? Huh? Minimum, sure. Why not maximum? Because that is the law of entropy. So, that means these particles are going to have the minimum possible surface area, inert in nature. Anyway, coming back to the point, this transporting agency is also going to shape up the whole morphology of the particle. What is morphology? Shape, size, roundness, irregularity, you know, this is a perfect sphere. I could have drawn a sphere like this. The particles are like this also, irregular shaped, clear. There could be a particle like this, flakes, okay. So, it all depends upon which transportation agency is acting to transport the weathered material which is coming out of the rocks. It is expected that the water is going to create a system of the particle which is near spherical, shining, very good looking, fresh quartz, pinkish color, peculiar properties of gangetic sands. Alright. Mostly aerobic process is controlling the whole process. I hope you understand what is aerobic process. Now, I have interlinked environment engineering with the geotechnical engineering. So, this answers your questions of bioactivity and you know what is happening and why and all those things, clear. So, the texture, the shape and the color gets guided by the transportation agency. So, be it water. Now, tell me, if I replace water with wind, what is going to happen? What do you expect?
Fine particles.
Good, fine particles. The most important attribute would be wind, associated with wind. Huh? Very good, light, excellent. So, weight of the particle, clear. We call it as a specific gravity. So, when wind is playing an important role, what is going to happen? Particles will not be so smooth. Why? Wind is not so abrasive in nature as compared to water. You agree? Is that is correct? That means here the chances are that the particles are going to be more irregular but lighter in nature. So, what is the problem associated with pollution in NCR, which you are reading in newspaper, and what soil mechanics guys can do? What role they can play? This can be a good question. What could be the role of a geotechnical engineer in stopping the pollution of NCR? You are a civil engineer, you are a geotechnical engineer. What are your views on this? This answers your point also. So, when wind is playing a role, particles are going to be mostly not very rounded, number one, they are going to be lighter, so that they may become airborne, otherwise they will not get lifted up, alright. So, these particles are going to be lighter as compared to the particles which are being carried or transported by water. Difference is clear? They form dunes. Jaisalmer, go to the places called Sum, you must have been several times, or you are studying all the time. Badmer, alright, Rudali and all these Hindi movies you must have seen, they show big dunes and they keep on migrating from one place to another place. Clear? What are the challenges associated with this? Let me complete this part of the story, that I will forget. So, these particles are going to be lighter, their structure is like that. So, if you take a particle and put it beneath the microscope, SEM, scanning electron microscope, you will see that they are very furry. Furry, you understand? They will have a lot of protrusion, furs. Why? They have to become airborne, they have to get airlifted, clear? And they form aerosols. So, half of the problem of NCR is because of, in summers, dust storm, in winters, these particles which remain in the air, they form aerosols, agreed? And that is the problem. How would you solve this? Rejuvenation of what? Deserts. Clear? How? Is a big question. But we are talking about some process by which I can convert soil into a rock. I can use this over here also to get rid of this problem. Try this at a global level, not in the laboratory. In laboratory enough experiments have been done, read about that. Clear? These are the answers to the question which you are asking. So, mostly these type of soils are known as aeolian. I will talk about all those things, do not worry, just you understand the concepts right now. Okay. How about the size? When they are getting airlifted, airborne, particle size has to be extremely small, clear? So, next time when you go to these deserts and all these places where the dunes are, you touch the sands, and if you rub it too much, the chances are that you will cut your skin and you may bleed. Why? Irregular shape, these are very sharp edges, okay. So, they are so irregular shaped, very sharp cutting edges, okay. So, the moment you touch them, rub them on your palm, the chances are you may bleed, okay. What about the color? There is no washing going on with water. So, color is going to be muddy, not so sparkling, shining, pure form of the colors. These are going to be mostly brownish and dirty looking colors, alright. Done. How about the ice? We will talk about this very special category. So, water, wind and gravity is again a sort of a combination of rock fall, but normally we do not consider gravity as a transporting agency. And then man-made, what we were talking about. The second category is residual. So, again I will repeat, geological classification of soils is like soils get formed because of weathering, and then a transportation agency comes in the picture, it transports the material from its original place or the formation place to the another formation, which is deposition. I am using the word formation two times. One is a process formation, another one is a deposition of, and the formation which is because of the deposition. Is this okay? Fine. In residual, it's a different story altogether. Incidentally, these are very good building materials. Lot of pozzolanic activity. Read my paper on desert sands of India. I don't remember the exact title, but this is written I think long back. This is a classification of desert soils from India. Let me just check it on my website. Alright, but there is a paper on this in engineering geology, and that paper is quite in demand because most of the guys who are producing cement, they want to use this technology for using directly the sands into making concrete. We are negotiating. Alright. Now the residual ones are the ones, as I said, they were formed, very unfortunate, nobody allowed them to move out, they got created there, clear, they formed there and they got disintegrated also there. But in the process, these are the best soils where, as far as the economy of the nation is concerned. Any guess? No. Another guess? Economy is always what? Hydrocarbons, oil and gas. Nothing can beat that. You agree? Yes, okay. So these are the soils which are the best deposits of what? Best deposits of what? Hydrocarbons, oils and gas. Why? They got formed, they could not get transported, they remained deposited there and they got disintegrated because of microbial biological activity. So these are the ones who are storing maximum reservoirs of hydrocarbons. Now tell me which one is good or bad? No one. I think this is what we were discussing during break. Agreed? Intentionally I gave you this example. So my job is, whether this is with me or whether this is with me, what I am supposed to do? I can always switch over my dharma. Here I will be a beautiful geotechnical engineer, and here what I will do, I will try to help the guys who are into hydrocarbon exploration, because without my help they can't do any exploration, remember. So I can earn both ways. That is the art of practicing geotechnical engineering. Is this part clear? I use the word art of practicing geotechnical engineering. That means the concepts remain same. What I have to do? I have to just use this material the way I can, and here my strategy will be changing. So I will use different strategy. So residual soils are the ones who remain deposited after getting generated at that place. So there is a typical way of showing this. The upper layer is known as upper zone, okay, and then is followed by the intermediate zone, this is the schematic diagram for depicting the residual soils, followed by partially weathered zone, and this is followed by the parent rock. Alright. So this is how the depth varies, this is the extent, and this becomes a strata for me. So most of the regions of Bombay, coastal areas where we are right now, if you have to learn geotechnical engineering, the best places are coastal areas, not the Gangetic plains. So this is a subject which flourishes in coastal areas. Why? Okay. Any questions? So, here we will have size, shape, texture, angularity, which petroleum geotechnologists have to learn from you. He is amazed to see the role which civil engineers and geotechnical engineers have to play. What was in your mind before, let us say 29th we met or 29th we met, is it not? So, when these snow, what you call them in the layman's language, on the hills, when they slide because of environmental changes, they carry a lot of soil along with them and soil gets transported. This is what is known as transportation of soils through ice. Okay. Yes, anything else? Okay. Now, 5 o'clock. All right. So, let me give you now few examples of classification of transported soils now. So, different types of transportation soils, transported soils. The first one is, depending upon the transportation agency, all these groups have been created. You know what is alluvial soils? Sometimes you may say that these are the deposits as well. What is an alluvium? What is alluvium? The soils which have something to do with the water. Clear? Alluvium. Check the dictionary meaning of the word alluvium. Check the meaning of all these words which I am going to write. Clear? And try to remember them. Yes, Manan. What is the meaning of word alluvial? Correct. That means the soils or the deposits which have been created by running water. Running water is important. You see, each and every word is important. You know why? Suppose if it becomes stationary water, class changes immediately. So, as far as stationary things are concerned, it becomes a different class altogether. So, running water is very, very important. Why? Because running water will give that abrasive effect, cleaning effect, alright. The particle will be very strong because it has undergone all that hydraulic pressure starting from Himalayas up to that point. Imagine how much robust the particle would be. Specific gravity is going to be good, clear, heavy particle, then only it is going to get suspended. I hope now you are getting a feel of how the attributes are interlinked with each other. What lawyers do, legal advisors, what do they do? They catch the words. No? You agree or not? In crime series and all these series, what do they show? The whole thing will start with a word and then it will end with the analysis of that word. So, in our subject, the terminology and the words are very, very important. Immediately I objected that it is because of the running water, not because of the stagnant and stationary water. Clear? So, whatever is getting formed in the Powai lake is different. Okay? Though this is also water, but this is stagnant water. And I am sure with your knowledge of environmental engineering now you can interlink very easily that this process is going to be linked with aerobic and anaerobic. Is this okay? The second one is this is my S, lacustrine. Lacustrine deposits check it on next dictionary. What is lacustrine? Basically, the term lac has come from lake. So, all these deposits are in the freshwater lakes. So, a lacustrine deposit of the soil is freshwater lakes. Is this okay? The third one is marine deposits. It so happens that the marine deposits could fall in both the categories. They could be transported as well as they could be residual, particularly in this Deccan trap. I hope you understand the word Deccan trap, the Deccan Peninsula of the country, starting from let us say Nagpur onwards up to the Cape of Cameron. This is your triangular portion, we call it as a Deccan trap. All along this Deccan trap, the soils which you get in the coastal regions are marine deposits. It could be because of delta formation we were discussing, suspended particles coming, and because of the density contrast of the fluid, they get deposited and they get formed over there. We will talk about the marine clays again when we talk about the residual soils. Granite gets decomposed, fine. Somebody was talking about black cotton soil in this sector. I am now hinting on that. Granite getting decomposed because of temperature, pressure, salinity of the water, the way the dissolution of limestone was taking place. Agreed? There is no agency which could have transported it, because sea waves cannot really transport sediments, though people study sediment transportation. So, please do not misunderstand what I am saying. Those of you who will be taking course in the offshore engineering will realize this very soon, that these residual soils are the ones which got created because of the weathering of the granite or basalt, clear, and they remain there. They had lot of organic matter in that themselves, they got disintegrated because of bacterial activity, and they got converted into clays. Clays is another variety of soils, what you were referring to, mud or slush. Slush and mud are not technical words, clear. So, we have introduced two words today, one is sands, another one clays, fine. So, the residual soils are also one of the types of residual soil would be marine clays, and in marine deposits also we can have transported marine deposits. Mostly these are the suspensions in sea water. Then we have fourth category as aeolian. We call them as aeolian soils. What are aeolian soils? Aeolian, A-E-O-L-I-A-N, aeolian. Aeolian has something to do with the air, clear? Aero. These are the soils which have been lifted up by wind activity, and very fine particles they got deposited, and hence aeolian. So, most of the transported soils which you have in the Jaisalmer, Bardmer, Bikaner, the western part of the India, these are all aeolian deposits, clear. I do not know how many of you are aware of or not. There was a time when Bombay High used to produce most of the oil for the country when I was a student. Now, what is the scenario? I have hinted everything, 90% hint I have given to you. So, check it on the net. The western part of the country, particularly the deserts, are the places where now most of the oil companies have started their production. Why? What were deserts earlier geologically? Answer this question to yourself. So, most of the oil companies are now concentrating on the western part, the bordering area of Pakistan and India. At least there are new 9 fields, oil fields, which have been identified, and the work is already going on in a big way. Imagine when you see in Hindi movies these dunes migrating from one place to another place, what is the biggest challenge? Huh? Sorry? Direction of what? No, direction is not a problem. Okay. Technical issue. Yeah. They are rolling dunes, is it not? They keep on shifting. How to make a structure stand on this? I said oil production is being done. How to create the facility, infrastructure, storage tanks. You will produce something, you have to store it somewhere, no? Have you ever seen an oil tank? No. You go to Oran side, there are big tank farms, Morvi, all over the country, the entire coastal area where you have marine deposits, these are the places where the oil is stored. Anybody here from Visakhapatnam? Nice. Why Visakhapatnam is famous as far as petrochemicals are concerned? What is that? I am talking about something different. I am talking about, see, connect with the context of the discussion. Yes, I was talking about the oil industries being operational in that region, and then suddenly I ask you a question: how many of you are from Visakhapatnam? What is the meaning of that? I think I was discussing about where to store the oil. That means naturally I am trying to hint you at what's happening near Visakhapatnam. Oil extraction cannot be done onshore. This is a place where big caverns have been created inside the ground, where the oil from the entire country, crude, is deposited, and from there again it is shunted to refineries. So it has become a big money chest for the country. You know what is money chest? You know what is money chest? Check on the website of RBI. What is money chest? Where they keep the money safe. Clear? A lot of civil engineering is involved in that. So these are the places where most of the oil is deposited. Why? Big question. So whatever you are producing, what I was saying is that these deposits are very good in hydrocarbon. Even these deposits are very good in hydrocarbon. Why? And then I asked you a question: what is the similarity between coastal areas and the deserts geologically? Okay, so try to understand this question and try to get the answer to this. Okay, next one. The common linkage is hydrocarbon, and the question is, if these deposits are not very stable, how I am going to create infrastructure on the top of it? So it so happened that after you have created a oil tank which is normally 60 meter in diameter, 60 meter diameter is minimum, 45 meter is the height. This is the height of a typical crude oil storage tank. Fine. Now you measure it and realize how big this size would be. You can play cricket inside easily. Now these systems are going to sit on these deposits, because just now I said that there are 9 fields of hydrocarbon. Very actively people are working on them to extract the hydrocarbons. Now how would you make them stable is a technology. It's not engineering, because people don't have much idea about how to do this type of work. So most of my clients are from BPCL, IOCL, Indian Oil, Shell, Burma, and all this. So I designed most of the foundations for the tanks for them. And right now in India is a big movement. You know, everywhere, every city, the major issue is India should be self-reliant as far as the energy is concerned, because our need for the energy has gone up so much. You must be a kid when there was a big discussion in the parliament on whether India should go nuclear or not. Dr. Manmohan Singh was the prime minister at that time. Try to find out what geotechnical engineers have to do in this context. That will be another role which you will realize what geotechnical engineers have to play. Okay. Then comes the glacial deposits. I think I have given you enough idea about glacial deposits. Anything which is formed due to ice. The sixth one is volcanic. You can say volcanic deposits. Why not? From a volcano, when it erupts, what is going to happen? Under very high pressure and temperature, the rocks, they get molten. This thing starts flowing. So, this is your molten lava. And what happens? This molten lava comes and settles somewhere over here and forms the igneous rocks. And many times, because lot of air or the gases get trapped in it, there are vesicles. We call them as vesicular igneous rocks. This is the process of formation. If you get a chance to go to Japan or the countries which are quite heavily affected by volcanic activities, what comes to your mind would be a big challenge to a geotechnical engineer? In this context, you will be having a lot of settlements over here, is it not? A lot of buildings and so on. There are a lot of YouTube videos which are available. So, I was talking about the management of the lava, alright. So, what happens is, I hope you can realize, a big task would be how to safeguard these settlements against the lava which is going to come out. Imagine what will be the temperature. So, most of the guys are doing river training work. If you check it on net, what is meant by river training work? They may train the river entirely. One of the examples of the river training work would be in Germany. They have done beautiful work. Just check it. What are the cases where they have bypassed the entire village, and they have done a colon surgery. I have in fact answered the question. So, very close to colon. What they have done is they have trained the river in such a manner that a village used to get flooded every now and then. So, the whole river has been shifted. Check it on net, and that has been made as a now canal which is being used for commercial purposes. So, let us talk about quickly the residual soils. But I have already discussed, most of these soils are upper zonal, intermediate zonal, partially weathered soils. They might be having a lot of organic matter in them. A good example of this is muskeg. I do not know where these deposits are in India. Check it. Why this is important? Just to sum up what we have done today before we go. See, I have given you a complete philosophy of what this material is. Clear? In geotechnical engineering, we are talking about the materials which are either soils or rocks, and I have given you a complete philosophy and overall picture of how they are getting formed, what are their attributes, what causes them to resettle somewhere, clear, and how to utilize them. In other words, I have talked about 3 states of the material: past, present and future. So, future is all about the engineering. The whole idea of this discussion is to give you enough background about the material so that tomorrow you can use it the way you want to use it.